Hi, it's Rich from Loen.Design. Today's video is a little bit different. Instead of making something, we're going to go over one of the new tools in our shop, which is the Aciera F5 mill. We had always planned to have a Bridgeport mill here in the shop, and we'd see them come up at auctions, and for whatever reason, they're really expensive in Canada. They were $6,000, $7,000, $8,000, $9,000, $10,000, and it just seemed a bit much for a mill that I knew I could get in the US for much, much cheaper. And so we kept looking and looking, and finally through our contacts, we found this F5 mill, this Aciera F5. And it's a Swiss mill, very, very high precision, used in the Swiss watchmaking industries and all that. And it's got a whole lot of features. It's a very big, substantial, heavy-duty mill. So we're really, really happy to have it here in the shop. One of the neat things about this mill is when we got it, we looked and some of the stickers on the back showed that it was from the National Research Council in Canada and was bought by them around 1980 or so. And what's interesting about that is both my brother and I had summer jobs at the National Research Council of Canada at that exact time. And when I showed some pictures of this to my brother, he was saying he worked in the laser and plasma physics department at the National Research Council. And in their machine shop, they had this mill, and this is one of the mills he learned how to machine on. So things come full circle. When we first got the mill in the shop, we had it wired up with 575 volt electric 3-phase power. And our electrician wired it up. We have a wire coming down from the ceiling here. We hooked it all up, turned it on, and dead silence. The entire machine didn't work. And the electrician came over, tested his connections, and said, "My work here is done," and left. And we were left standing, staring at this machine, going, oh my God, it was such a depressing day. We took apart the electrical panel, we took the cover off, and I was measuring voltages all around, and it was there. The voltage was there, the 24 volts was there, all the relays were there and clicking, and they did what they should do, but the thing wasn't working. And what we finally found out is that there are some interlocks on the machine that stop it from working if things aren't set right. So one of them is for the spindle lock. There's a spindle lock at the back so that when you go and change in a new tool, you can do that. If that spindle lock is in, the machine won't even power on. And the second one is on a holder over here. This whole front part with the quill comes off, and there's a thing here that connects onto that, and then this whole thing swings over. And there's a little switch here that if that isn't depressed, the whole machine won't go. And we had been playing with this. It was sitting out like this, and the machine wouldn't turn on. So once we clicked that in place, then the machine powered up. So it was a couple of little tricky things like that. There's very, very, very little video or information about this mill on the internet. There's a couple of places you can go and find PDF files. They are incomplete. They're sort of user manuals, not really, really helpful. And there's maybe 1 or 2 videos we found on YouTube where somebody is using the machine, making it move and things. So we wanted to do a little bit more in-depth look at it just to see what we've learned about the machine. We can share it with you or anybody who wants to buy one of these. The machine has a control panel down here with this big stop button, a main power, coolant, hydraulics, and spindle, forward, reverse, and on-off. And so all these controls are here. There's a whole second set of buttons over here, and in fact a whole workstation here where you can control the whole machine, every axis, from over here. And that's kind of strange. So you can machine from the side of the mill or in front. So it's a little bit different way of laying out a mill than what we're used to. Well, let's turn the mill on and see how it goes. You'll hear the whining of the hydraulic motors, which go all the time the machine is going. So we have all the little controls that are red move an axis or do something to the machine. So here, if I want to put this on, I have my speed going here. So this is through a hydraulic motor making this go. And if it gets to the end, it automatically will stop. And you can turn on, I can make it go up, and I can make it go forward. So now every axis is moving. And then when an axis is moving, we had this big pedal here, and we thought, oh, that's cool, that's kind of must be a brake or something for the spindle. It turns out it's a fast move of an axis. So when you press down on it, you can move something really, really quickly. The harder you press, the faster that goes. And we have another one over here. So if I'm moving this axis, I pull this lever. It's the same thing. So you can move things and position them around by pulling here fast, pressing the lever. So that's pretty cool. So this is the side control panel for the machine, and here is the speed control for the spindle. And you have a sort of a gearbox selector here, which is either the green range or orange blue, and then down here it's either green or orange or blue. It says here, manœuvrer à l'arrêt, which means change it while the spindle is not going. And while I'm here, I can move the head in and out. And you can do it manually. So these are all loose. You push it in, it clicks, and then you can move it. So I can move the head manually here. And it's all in thousandths of an inch on this machine, which is interesting for a European machine. The mill comes with a DRO from the 1980s, so it's pretty old electronics. It's still working fine. One of the next projects we're going to be doing is switching out this DRO for a newer one from DRO Pros. I've used them on other machines here, and their stuff is fantastic. Their support is amazing. So this is the vertical milling head, and as I said, you can remove this right off the machine, and it just swings over to the side out of the way, and there's a whole horizontal milling head that goes on there as well. So we have those parts. So if you want to be doing horizontal milling, you can do that too. The vertical machining head can tilt as well. And you have a scale right here on the side. You undo some bolts, and the whole table will, or the whole vertical part will rotate. That's not something you do very often, but when you need to do it, it's really convenient to have it there. The vertical milling head has a tool change thing up here. So we've actually modified this to work with Cat 40 tooling, and the original one that came with it only worked with NMTB 40 tooling. So this is the tooling that the machine was actually designed to work with, and this is an NMTB 40, and it fits in here, and then you tighten down the tool. It uses the same 5/8 11 thread as Cat 40, but it has this extra bit on top. And so you need a shorter bolt coming down. And in fact, what we needed was a longer bolt in order to use standard Cat 40 tooling. This is more modern. So we made some adapters, and we bought a bolt. So we bought this bolt off McMaster Carr, and then we have an adapter on here that we use for the Cat 40, and this adapter for the NMTB one. So that it's the difference in height here is the difference between the height of the two tools. And that way it lets our thread engage. And there's a way of locking the spindle, and I'll show you later. It's from the back of the machine. You just push something in. And when you do that, the motors are disengaged and everything, so the machine won't start while this is locked. Now, on the spindle, you have a quill here, and you can read here in thousandths. And you have a thing here where you can lock the spindle so it won't go up and down. You can lock it at any height. Or you can use this fine feed control. You can connect that in. And to do that, you loosen this up. And then move this around like that. Now it's engaged this thread into the vertical motion. And now I can move the spindle up and down, and I can read my values off of here in thousandths of an inch. And you see the quill still moves. You can undo that here and have it all disengaged. So this was entirely seized when we got the machine, and was a really, really difficult thing. Like, we were really wailing on it trying to make it work, and then finally we got it sort of working. It's still a little bit fussy, but it's a really neat thing that you can just by, there's sort of an offset mechanism here that basically moves the whole thread in contact or out. So this whole screw goes in to contact the quill or moves back. One of the first accessories we bought for this mill was a nice vise, and we got this from Glycern Machine Tools. And it's just a beautiful device made for CNC machines, but it worked great on this mill. And we have a speed wrench for it, which makes it nice when you're doing a bunch of tool changes and whatnot. And while we were there, we ordered a bunch of tool holders from Glycern and a chuck. And this is nice because it's a completely integrated chuck and all that, very, very high precision. So I'm not pushing Glycern Machine Tools, it's just we ordered a bunch of stuff from them, and the things that came were fantastic, high quality stuff, so we're pretty happy with it. One of the cool things this machine has is built-in cooling. So there's a compartment down here on the side, and there's a bunch of coolant fluid, coolant and cutting fluid here. A little reservoir for that, and a little pump. And the coolant comes up here, up this pipe. When we first got it, it didn't have any of this link lock on it, and it was just sort of pointing out. And I was always sort of paranoid that somebody was going to turn on the coolant button and this stuff would just start shooting out across the room. But so I put this sort of temporarily on here, although it's probably going to end up permanent. So I have some way oversized link lock tubing, but you can bring that right in and get cooling as you're doing cuts. So that's sort of a nice part of the machine. It's all built in. The machine has a really nice big table, and we keep it covered so that we don't get all the swarf in all the grooves while we're working with it. It's a nice big table, easy to fasten things down. And one of the really crazy things about this table is that you can actually move it as far as, so the movement what we have is about this much. So that's not even the whole length of the table, it's about half the length of the table. But you can move the table up about halfway, and then you can actually undo a couple of screws and move the whole machine mechanism back while the table stays still. There's a little clamp over here, you tighten it down and you loosen up the screws on the bottom, and then the whole underlying mechanics of the machine move this way, and then you clamp it back together, and then you gain access to this whole part of the mill, or the other half of the table. So that was a really surprising thing. To be frank, I haven't done that yet, but it's a neat thing that you do have access to the whole size of the table when you're doing machining. You might just have to sort of do it in two halves, and I guess re-zero things when you're doing that. We're around at the back of the machine. This is the main, is connected down to the motor through the variable speed mechanism. So you can turn this and turn the spindle. And this is the spindle lock I was talking about before. When that's pushed in, the whole mechanism is locked, and that's when you can tighten and loosen the tooling. And if this is left in or gets pushed in by somebody walking by, the whole machine won't run. So there's an interlock on here, and that's one of those little gotchas that, oh my God, the whole machine's not working. That concludes our tour of the Aciera F5 mill. I hope anybody who's bought one or is looking at buying one will find that interesting, and anybody who's interested in older machine shop equipment might find it interesting too. Thanks. So it's not supposed to look like that. That being the belt, the drive belt for the F5. See if we cut it 3 inches too short. Don't do that. There we go. Just pull it out that far. Maybe Chris will have a shit fit because I'm using the wrong terminology for everything. Falling all over the place. It's you call that stuff that you have at Christmas there, eggnog. We use eggnog for coolant in Canada. It's fantastic stuff. I love the eggnog. Good for coolant, a little bit of rum. And don't forget to click the subscribe and the button and the bell and the thing, because it really helps us out. Just click everything right on your screen. It's important to go around now and click on every button, every little thing. It'll all be good. Don't worry about any ads, pop-ups, the donate now things. It's all good. Just click it all. Click everything. Or maybe just click subscribe. Maybe the like, the little bell, all those. That's it. Thanks. Don't click anything. Absolutely don't click anything. Just sit here. And I'm going to sit here and we'll just watch each other for a little while. I like your haircut. I'm curious as to when it gets awkward. It's not awkward for me. I'm enjoying it. You really have done something different with your hair. Like, it's nice. I could stay here as long as you can. We have to get this video to 8 minutes, so I'm good. All right, now it's awkward. We've reached that point now. This is the point I reach 7 minutes after arriving at any dinner party. I'm done. I've said everything I have to say. And then you have like hours left to try to think of something to say. You have no clue. That's when you tell bad jokes. I visited the worst zoo in the world the other day, and they only had one animal. It was a dog. It was a Shih Tzu. People leave me alone at parties. Shih Tzu. Like it's a kind of dog.